Part A, I'm going to make a substitution here because I can see that this is a quadratic involving 7 to the power x. So I'm going to say let t equals 7 to the power x, because that way t squared would be 7 to the power 2x. So I can replace this with t squared, and I can replace this with t. So that's going to give me t squared minus 4 times t plus 3 equals 0, which can now be factorised easily to be t minus 3, t minus 1, which means the solution to this are either t is 3 or t is 1. We know though that we need to work out x, not t. Remember that my original substitution was that t is equal to 7 to the power x. So if I say 7 to the power x is equal to 1, or 3 rather, or 7 to the power x is equal to 1, I can now take, and again there's a couple of different ways we could do this. I'm going to take logarithms of both sides. Bring the x down. And then divide both sides by log 7. Which, if I put that into my calculator, I'll get 0.565 to 3 significant figures. For the second equation, 7 to the power x is equal to 1. Well, I could go through all that process again of taking logarithms and so on, but actually I don't need to. I know that 7 to the power of 0 is going to equal to 1. So I know that x is 0. So these are the two solutions to part A of this question. Part B. Same idea. I can see that this is going to be a quadratic. So I'm going to say that let t equals 3 to the power y. That would mean that t squared is going to be 3 to the power 2y. Now this one's a little bit more complicated because I've got a 3 to the power 2y plus 1. So I need to do a little bit of work with index laws on this. I can rewrite this as being 3 to the power 2y times 3 to the power 1. Or just swapping those around, 3 to the power 1 times 3 to the power 2y. This is my t squared. So I'll get 3 times t squared minus 11 times the t minus the 4 is equal to 0. This can now be factorised relatively easily. I know it has to be a 3t and a t to give the 3t squared. I think it's going to be a 1 and a 4 to give the minus 4 on the end. Maybe a 1 and a minus 4 like this. So I know this times this gives me this, so that's correct. I think this times this gives me this. And I just need to check for the minus 11t in the middle. This would give me minus 12t. This would give me 1t. And the minus 11t, minus the 12t, and the plus 1t gives me the minus 11t. So I know that t is either minus 1/3 or t is 4. But we know that t was actually 3 to the power y. So let's swap those back. Now, 3 to the power y is equal to minus 1/3. That's not possible. I can't do 3 to the power of a number and get a negative. That is impossible. 3 to the power of a number is always going to be positive. So there's no solutions to this. By all means, you could take logarithms of both sides and go through the algebraic process, but you'll find your calculator will just give you no solutions to that. Second equation though, there will be solutions to this. So let's, like I just said, take logarithms of both sides. Move the y to the front. And divide both sides by log 3. And on your calculator, you will get to 3 significant figures, 1.26. And that is the only solution to that second equation.